Welcome to this short series on ABAP development tools for VS Code. What will you learn here about installing and getting started with ABAP using VS Code? We'll start with the following agenda. We'll give a brief introduction to the new architecture and everything else you should know when working with VS Code. We'll look at the installation and setup, and then take a short tour of VS Code to familiarize you with its features. In the next section, we'll explore Agentic AI, how to configure it and how to use it later. At the end, you will get a brief overview and an outlook on how the extension will continue. So let's dive right into the topic and learn a bit more about the extension and the releases. Let's look at the different development tools over time, starting with the SAP GUI and the various transactions available to us for carrying out development. In the past, this was primarily about full-stack development, meaning we modeled the database, built the UI, provided the transaction, and the user could then work with it. In other words, we did all our work in one tool. Then the ABAP development tools, or ADT for short, were introduced, initially in the Eclipse version, which is now over 14 years old. Over the past few years, this version has become feature complete, meaning we have all the functionalities we need to develop applications in the cloud. However, the full stack development aspect is missing, as we only handle the ABAP backend and the Fiori app is created in a separate IDE. The version for Visual Studio Code has now also been released within the ABAP Development Tools suite. This is a new IDE that will support the same functionalities in the future, but is primarily designed for Agentic AI and the complete developer workflow for full-stack development. The overall goal is to create a single IDE for complete full-stack development. We want to eliminate the need to switch tools and instead be able to manage the entire application lifecycle from back-end to front-end components directly within the IDE. This offers the advantages of speed, consistent tool usage, and reduced training requirements. Currently, Visual Studio Code is the IDE, but it is also possible to support other derivatives, such as Business Application Studio. Since this is an initial scope, the Visual Studio Code plugin was implemented first. Implementation in Business Application Studio would follow later, and is primarily relevant and lucrative for companies with a strict company device policy. This means that installing new software is relatively difficult, and not every user/developer has the necessary administrator rights on their computer. However, we also see advantages here, as the installation and management of plugins is eliminated, and the virtual environment handles this for us. Something for the lazy developer. So what does the new architecture for the development environment look like? You should have noticed that the last two updates were relatively large and took a long time. A new architecture was rolled out in these updates. The focus is now on the language server, a so-called LSP server with the language server protocol, which provides all the functionalities of the development environment, such as code highlighting, validation, and interfaces. This server ultimately connects to the SAP system, and our IDE essentially only communicates with the language server. This has the advantage that we can use different IDEs that support the language server protocol to develop against our SAP system. The only difference lies in the UI components, which must be developed individually depending on the development environment and can therefore vary. According to the development team, this allowed them to reuse 60% of the code, which now runs in a Java language server. At the same time, the architecture of the MCP server, which our AI requires, was integrated into the language server, so that it runs centrally on the developer's development machine. What should you expect from this new development environment? Basically, the initial scope was full-stack development with REP. The most modern stack in ABAP Cloud was used, so that all artifacts required for a REP application are available. However, this primarily refers to table entities, data definitions, and simple types, not to classic tables. All lifecycle components are present, such as unit testing, the ABAP test cockpit, and everything we need for AI. This includes, for example, the MCP server, which also contains the REP generator, as well as tools for activating and executing unit tests. Agentic AI was implemented using Copilot, a standard plugin for Visual Studio Code. Support for all systems, whether cloud or on-premise, is possible from release 7.31 onwards. While the initial scope did not include basic authentication, this has since been added. And of course, basic debugging is also possible. Which components are currently not included? Classic reports and tables are not included in the feature set, nor are many elements that require the SAP GUI. Some UI functionalities, such as IDE actions, The transport organizer and the data preview are also currently unavailable but are planned for release in future versions. Somewhat surprisingly, creating new packages is not possible via the development environment. Here you have to use a helper class and the Xcode library or Eclipse. The lack of an ABAP cleaner is also somewhat disappointing. However, this is expected to be released relatively soon, also as a plugin for VS Code. Let's take a look at the software installation. All we really need to do is search for Visual Studio Code. There we'll find a download page for all common operating systems. And then we can install the plugin within the IDE. We'll take a look at these steps live on the system and perform them step by step. Use your preferred search engine, as you'll find the Visual Studio Code installation page and can download the appropriate version. In this case, we'll choose the installation file and not the compressed zip file, since we want to install it on our system to use it as a permanent IDE. After downloading, we'll perform the installation and click through the wizard step by step. Where should it be installed? Which files will be associated with it? And how do we want to handle this in the end? After the installation is complete, we can start Visual Studio Code for the first time. In the top area, via the toolbar, we can enter a command and search for color theme to adjust the settings. Here you can choose between different themes, whichever you prefer, light or dark. We'll choose a light theme, as this offers better contrast, especially for presentations or displays. In the sidebar, you'll find the extensions section. There you can search for and install new plugins. We'll search for ABAP development and find several plugins in this area. The official ABAP Development Tools plugin is listed third. We'll start the installation using the Install button, thus installing the plugin in our IDE. Now we can start working with ABAP. Before we really dive into the IDE, we want to give you a brief overview of the IDE and the various functionalities that are important for working with it. This overview image shows you various information about the window you will see. On the left is the toolbar. We already used this to install the extension. There you will also find other tools such as debugging, the Explorer and the Git connection. Right next to it is the so-called Workspace area. This is where all your working directories are stored, which you will create later, such as connections to systems or individual packages from systems. Once the code is open, you'll find the outline directly below. This is there to visualize the object structure. At the bottom left, you'll find the accounts and settings. These are especially important if you later want to connect to the GitHub plugin or log out again. This function is easily overlooked. In the middle section, you'll find the editor, the main tool for editing and modifying files. Above it is the command palette. This is particularly important because Visual Studio Code doesn't offer all functionalities through the UI. Some functions can only be accessed via commands. You enter these commands in the upper section. You can click on the bar once to start entering the command. Or you can press Ctrl plus Shift plus P to enter the command immediately afterward. In our image, you can see the Copilot on the right. This is already pre-configured and populated with initial information. This will be needed later to work with Agentic AI. To connect to a new system, we need to create a destination. To do this, we go to the command palette and search for ABAP New Destination to create a new configuration in the editor. Currently, two login methods are available. Via RFC, for example, to private clouds or on-premises systems, or via HTTP to connect to cloud systems. In the case of RFC configuration, the next step involves selecting the configured local systems that are provided via SAP Logon. Settings such as client, username and language must then be configured to log on to the system. In this case, we want to connect to an ABAP environment, so we'll use the HTTP destination. The first step in the configuration requires providing the system URL. You can find this relatively easily. Simply log on to the Fiori Launchpad once, copy the URL and paste it here. Finally, we give the system a name. Here we can use the system ID, for example, or we can specify a descriptive name that we will see again later. With that, we have completed the basic configuration of the destination and can now extend the workspace in the next step. In the workspace, we then work with the actual objects and systems. To get a system into the workspace in the first place, we have to add it. If we search for the command ABAP add, we currently find 3 different versions and have various options for adding objects to the workspace. Using add package as folder, as we can select a specific package from the system that we then want to include. Using add destination, we can add a complete system. This will then be displayed split into local objects and software components. As a third option, we can add only the local data of a system. For example, if we want to experiment with it for testing purposes. However, this option doesn't work very well with the ABAP environment, since we don't use $temp here, but rather set local as the local component. Let's select the option to add a package. In the next step, we have to enter the destination we want to connect to. Here we are asked to authenticate with the system first. We do this via the browser by clicking the first option in the dialog. After successful authentication, we can then search for packages in the system. Here we use our demo AI package, which we then want to integrate into the workspace. Finally, we can choose the name for the virtual file system structure. In this case, it consists of the package name and the system name. We'll leave it as is for now and accept the changes to create our workspace, which we'll then use. Before we can work with the workspace, however, we need to log in. We can tell we're logged in because there's an exclamation mark after the name, indicating that we're not yet logged in. To log in, simply right-click on the folder and select the first option, Log on to Destination, to authenticate with the system and load the corresponding structure. The package is now open, and we see the first two parent packages present here. Since Visual Studio Code is a web component-based application, we can easily scale the UI without restarting the IDE or changing any system settings. Using the plus sign, we can activate the zoom and increase it by one level. You'll find a corresponding plus symbol at the bottom of the editor. There you can make further adjustments or reset to the default settings. We'll increase it one level here so that we can read the elements more easily for the video. In the past, we had the problem with Eclipse that while we could increase the size of the source code, the individual UI elements didn't change, which usually led to readability problems during presentations and demonstrations. What's immediately noticeable when opening the package is that there's a JSON file containing the package configuration. These are objects that aren't present on the system but describe the actual packages, that is, the files. When we open the package, we find the familiar structures such as the source code library, which we can further expand to access classes, interfaces, and other source code-based objects. Here we'll open the reader as an example and find several more files within it. Generally, we can't open the class directly from the top menu item. Instead, we have to navigate to one of the files below. The first file describes the general class with the ABAP code. Here we can scroll normally and view the ABAP code. If we then want to switch to the test class, for example, we have to open a separate file for the test classes. You'll also find the general properties in the corresponding JSON within this structure. Where does this structure actually come from? Let's take a look at the Git project for ABAP file formats. These define the actual structure of each individual object. It's an open source project driven by the community and SAP to give each object a structure so it can later be stored in a file format. Let's examine the different file formats and look at the class. A class consists of various objects that describe the individual elements. Since a class primarily consists of includes and isn't contained in a single file, there are a correspondingly large number of files. For example, we see a configuration file that describes what's in the class, the source code file that defines the general part of the class, the various includes for the definitions, implementations, macros, and test classes, as well as further includes for the text elements present in a class. If a sufficient number of languages are involved, a corresponding number of includes are possible. In the back section, you'll also find various examples and can see how such a file is structured and what it looks like. Let's now create a new object in the system. To do this, we go to the command palette again and search for ABAP, create new ABAP object. In the next step, we can choose from the available file types. Here we see the currently bound types in VS Code and can get an overview. We want to create a new class, so we land in the corresponding wizard. We see in the upper section that we currently have to go through 5 steps to define a new class. In the first step, we define the package in which we want to create the class. And in the second step, we assign a name to the actual class. In step 3, we provide a description. Steps 4 and 5 can be confirmed simply by pressing Enter. These concern the superclass and the interface that we can include. Afterward, the creation of the new class begins, and we receive an empty class body that we can work with. As the next step, we want to define the interface for the executable class. To do this, we simply need to implement the interfaces and then search for if_00 after the first statement. Then we can start autocomplete with Ctrl plus space. Here we see both interfaces from the system and can choose our interface. However, the option to create the implementation for the method is still missing. This means we have to do the actual implementation manually. The convenient feature we also have in Eclipse is still missing. After that, we'll print something directly to the console to generate some initial output. You can find Format Document via the context menu or the corresponding shortcut. This allows us to start the pretty printer for the document and format it. The ABAP Cleaner isn't currently available, but it's planned for VS Code as well, which would greatly simplify document formatting and provide the standard functionality from the new world. In the next step, we need to activate the object. You'll find a button above the editor to activate the individual object. If you want to activate all inactive objects, you'll find an Activate All option below the editor. This opens a pop-up window where you can select which objects you want to activate. A normal activation process then runs in the system. To run the class, you can select the appropriate option from the Objects context menu or press F5 to start the class and generate output in the console. With that, we've created, activated, and executed a new class. Let's take a look at debugging in the new editor. As always, you can set a breakpoint on the corresponding line. This line will be highlighted, and we can then see the active breakpoint. Next, we run the application again with F5 and land directly in the debugging view. Here we find the basic debugging tools. This describes the editor, which is located in the middle section. On the left, you'll find the variable view, various watch points, and the system call stack. In the lower section, you'll find active breakpoints in the source code. A nice feature, the breakpoint is highlighted again in the lower section, when we're in debugging mode, with a red line. We also switch tools. On the left, you can see that we've switched to the Run and Debug area, which is quite similar to perspectives in Eclipse. Through variables, we have access to the various local variables, or can add new variables. We can open these and view their contents using the standard tools. This doesn't quite match the content we see in Eclipse, but is purely standard VS Code. At the top, you'll find a small palette for the different steps we can take in debugging. This looks similar to the debugging tools in the Chrome browser. You can move these freely. They offer various options for navigating through the source code, skipping a step, or jumping to other relevant points. These options correspond to the same options as in the Eclipse debugger. Basically, you need to understand that the keyboard shortcuts here are completely different from those you'll find in Eclipse. Pressing F5 runs the debugger and exits object debugging. Generally speaking, only the standard tools have been implemented so far, and further tools such as a more detailed variable view or better debugging functionalities and insights will be added later. Basically, this is perfectly sufficient for standard debugging and first steps. In the next step, we will look at working with unit tests and how we can execute them and view the results via the coverage. For this, we switch to the RSS reader. This is an implementation that we created using agentic AI to read and process our RSS feed. As a first step, we switch to the include for the test class to see that there is a unit test. Then we can go to ABAP Run in the command palette. Search and find various options for running unit tests, including the ABAP test cockpit within the system. Instead of a simple unit test, this time we'll create a unit test with coverage to examine the visualization within the editor. The test is visualized in the editor's UI, as seen at the bottom. Next, we switch to the testing tool and see the executed test class. We can see that the corresponding method was executed and passed successfully. Below this, you'll find the corresponding runtimes, just as you're used to in Eclipse. Below that, you'll also find a display of the test coverage, which is approximately 87%. To examine the class itself, we need to switch back to the Explorer and this time view the implementation. Here you'll find formatting and highlighting on the line numbers, and you can hover your mouse over the line. A nice difference compared to the Eclipse implementation is that here you can also see, for example, how often the individual sections were called. This means that our unit tests show which sections were tested particularly intensively and which weren't executed at all. What does it look like for you if, for example, we don't have a sidebar for an object, or if we want to quickly switch between different objects? To show this, let's reopen our initial class that we created. In the upper area above the text editor, you'll find the so-called breadcrumb menu. Everything is listed here, from the workspace and the various packages to the actual object we are currently working in. If we click on the element we are currently viewing under the object, we can, for example, switch to the test class within the text editor or to the other includes and artifacts belonging to that class. Alternatively, we can also use the paths that exist at higher levels. For example, if we click on the class, we can see all the classes currently at the same level, such as our database reader and the RSS reader as additional classes. If we open the RSS reader, we then see all the includes or files it contains and can also switch directly to the object within the corresponding include. The same applies to the options we find further up. This allows us to navigate down to the package level and then select objects within those packages to open them in our editor. This means the second form of navigation is via the breadcrumb menu at the top, which can speed up searching and selection. Agentic AI essentially describes how a generative large language model iteratively works on a problem. There is a so-called agent, which we define and which has certain properties and skills. This agent then processes the problem or the actual prompt and implements it in the system. This can create an agent loop. If, for example, the goal isn't reached, the agent continues working until, for example, errors are fixed and the code can be activated. For configuration in VS Code, we use Copilot. You have two options. Either you activate your GitHub account and log in with it, or you use an API key, for example, if you've subscribed to a large language model such as Gemini or Claude. Next, we need to activate further tools, in this case the built-in MCP server in ABAP. We activate this and then integrate it into Copilot, so that the tools are used. In the third step, we define the actual agent, our ABAP developer, who will later carry out the development and receive certain guidelines from us. In the last step, we could add custom instructions, which are additional work instructions that we can then assign to a prompt. However, this step is optional for now and we won't be performing it in this video. We naturally want to look at the next steps live in the system, so we'll switch back to our editor to configure it. At the top you will find the sidebar which we can open to see the built-in chat. In the chat you have various settings options at the top to create new chats, adjust settings, update or change the width. In the lower section you will find the input window for our agent, or rather our ABAP developer. If we click on models, we see that we currently have no models available. However, we can log into Copilot to load them. You'll find the Copilot icon in the lower section, and you can then choose how you want to log in, either via GitHub, Google, Apple, for example, or other authentication methods. After authenticating in the browser, we'll find further settings behind the GitHub Copilot icon. For example, we can see our used credits, and we can also disable inline suggestions here. These suggestions that Copilot makes while we're working in the editor also have disadvantages. When we're working in an empty class, we sometimes get suggestions that are completely irrelevant to our actual project and our actual class. Therefore, for the sake of simplicity, we'll disable the ghost text. If you now go to the model selection in the chat window, you'll find the available models offered via GitHub Copilot. Here we select Claude 4.6 Sonnet, as this model is perfectly adequate for generating ABAP code with good context. Behind the model you have further configuration options to increase the model's effectiveness or save costs, for example by reducing context performance. An important component for the good performance of an agent and for enriching information is an MCP server. This server is now delivered with the ABAP development tools and runs directly on the language server, as we already discussed in theory. Currently, however, this server is delivered inactive, and we must first activate it via the settings. To do this, we switch to the settings, for example using Ctrl+, and can then navigate to the extensions section. There you will find the ABAP development tools. Open them and scroll all the way down to find the settings for the MCP server. Before activating the MCP server, you can also set the port if you want to choose a different port on your device. After starting the MCP service, a corresponding message will appear in VS Code indicating that the server is now starting up. You might otherwise receive error messages if there are problems during activation. Let's now switch back to the Copilot chat. Here behind the selected model, we find the option to configure the tools. We click the button and get an overview of all the tools in our editor. This setting defines the tools that our agent is allowed to use later. Tools such as file editing and workspace search are already enabled here. The ADT MCP server is located in the lower section. Here you should ensure that all tools you intend to use are enabled. For simplicity, we'll enable all available tools. You could also disable write tools or tools that create data in the system if you only want to use read-only mode. The final configuration step is creating the actual agent that will support ABAP development. You'll find another option for this in the Copilot chat, this time on the left side of the model, where the agent mode or the agent mode icon is also active. Basically, you can create different agents, each with a different context and different instructions. For example, you could create a review agent that performs code reviews for you to ensure a certain code quality before you then pass the review on to your colleagues. We create a new agent in the system using the Custom Agent button. To do this, click on Create New Agent to start the wizard. Next, we need to define the storage location. Here, for example, we have the option of storing it in the current workspace, or we can also store it globally in the Copilot area so that the agent is available globally. In this case, we ensure that the agent is available for the Copilot and select the directory. Now we give the agent a name. This name is stored in the file but will also be displayed later when the agent is selected. A markdown file is then created, which we can now enrich with our instructions. Basically, an agent consists only of descriptions that describe the actual tools and which rules it should follow. No great magic involved. If you need to configure the agent initially, you can find further information in the SAP documentation. A test file with initial instructions is already defined here. You can copy this and then paste it into your agent. Later, the plan is to automatically include an agent.md file with the plugin initially, which you can use to configure a first standard agent. We will now insert our own agent file. In the upper section, you will see some configuration options such as the agent's name, a brief description of what the agent actually does, and various tools that will be available to the agent later. In the lower section, you will find information partly from the template and partly already added. So first, general information, and further down, instructions on testing. Since we have additional requirements, we will also include the topic of quality. For example, Hungarian notation should not be used, meaning no variable prefixes. Comments should only be used when necessary. The agent should adhere to the clean ABAP guidelines and use descriptive names for variables, thus fulfilling certain qualities that we want in our code. Finally, save the file and you're finished configuring the agent. The agent is now available and can be selected so that it's considered in the next chat. In the next example, we want to create a class from scratch that doesn't yet exist in the system. This means we start with our actual prompt and state that we need a class, which should also be stored in a specific package. We don't specify the name of the class yet. In terms of content, we say that Roman numerals should be converted to Arabic numerals. And we also need unit tests to validate that the logic works, and the various edge cases should also be tested. The LLM now begins working and first creates a to-do list for us. This means we can already see what the agent wants to do in the next steps. We can expand this to-do list and see, for example, that it first wants to retrieve the list of destinations, since we haven't specified on which system the implementation should take place. Next, it would create the class, then add various unit tests, and finally attempt to activate the class. Activation is important because we then determine whether there are any errors in the class, which is quite possible. The LLM then receives the relevant information and can correct the errors. In the upper section, the agent is already requesting the necessary permissions. We have to manually approve certain tool calls here because these are our default settings. You can find these default settings in the lower section and, for example, configure them so that all tools are accepted automatically. In this case, however, we want to maintain some control and examine the various calls. The first call is directly from the MCP server, and it's currently attempting to retrieve the available destinations. This means it wants to get an overview of which systems are available and which system it should actually be working on. In the next step, the large language model first validates the corresponding class name against the destination it found. That is, whether this class already exists in the system. We also accept this tool request. The context tells us what it's actually trying to do. In this case, it's checking the package to see if the corresponding class exists. The next request is then whether it's allowed to create the class. This means we say accept so that the class is created on the system, which is what it now does. On the other hand, we can then refresh the workspace and see that the class already exists in the system. However, it is still empty. The agent has initially created the empty implementation and assigned it a suitable name. The agent is now beginning the actual implementation process. This means that in the chat we can see what the agent is considering, which implementation it wants to create, what edge cases exist, and what else it should take into account. This is fundamentally interesting for understanding how iteratively the agent proceeds and what things it looks at and needs to consider. Currently, we don't yet have any changes in the system. This is the actual thought process running in the background. The agent has now made initial changes to the class. We can see these very clearly. Firstly, the class is now populated with the first information. On the left, we see all modified objects or includes that have already been changed. And below the to-do list, we also see that files have changed. Here is the opportunity to confirm or undo changes. Otherwise, the agent will simply continue. We can view the changes by clicking on the file. And in the callout, we see the modified lines, which we can then confirm with keep or undo with undo. You should invest some time in the review process here and look at what has actually been generated and whether it meets your requirements. The agent has implemented 3 methods. One for the actual conversion logic, one for validating the content, and another to retrieve the configuration of the various symbols. We can now click on the file and see that we land in the unit tests. Here the agent has already built a fairly large number of unit tests. We also keep these with keep. Finally, we confirmed that the class should be activated. Copilot then activates the entire class accordingly. If there are still errors, as in this case, it makes further adjustments to the logic. If the activation was successful, Copilot now wants to start the final unit test to check if the result is correct. Finally, we get an overview of what has happened. All unit tests have run, various edge cases have been tested, and the logic has been implemented. The actual agent loop is now complete, and we can view the result in the system. Our task now would be to validate that best practices are being followed. We can then, for example, either make adjustments ourselves or give the agent further instructions to modify certain code components with which we might not yet be satisfied. For the next example, we'll switch classes and look at the database reader. This is a small class that provides 2 methods for reading data. In the first case, we'll read the business partners and 5 rows from them. In the second example, we read a language configuration here via the key that we pass into the method. To do this, we switch to the test class and tell the LLM that we want to create a test class and test all methods within it. As before, the agent now looks at what we actually wanted to do, reads the actual objects and their types, and then starts to consider the next steps. The agent then starts working and decides to use the SQL double, which is perfectly correct in this case. It then generates some initial test code, which looks fine so far. However, we also see that there is already an error message, and the error message indicates that the method name is too long and needs to be shortened. Based on the error message and the inability to activate, the LLM immediately recognizes the error and begins correcting the code. As always, we confirm all changes made by the large language model. This is our last chance to review the changes. Next, the LLM still finds an error in the data. It sees that it cannot properly set an identification. Here the model assumed that when working with a language object or a language table, we would also pass the corresponding language keys. Now the model tries to read the core data service and find out what the problem is. However, the model will not find a solution because the core data service is not within the scope of the currently included packages. This means it cannot obtain any information about how the language is structured. Since we now see that the model is going in circles, we provide further information so that the agent can now fully complete the test. We specify that the identification is of type UUID and is a raw 16 field, so that it knows it needs to generate UUIDs here to properly populate the key. The model responds to our comment and adds a method to generate the key fields. Once the changes are implemented, we see that the class can be reactivated. However, when running the unit tests, the model also notices that the types used are incorrect, because the SQL double requires the database types and not the types defined in the class. Here, for simplicity and ease of use, we have specified local types. However, the original database type must be specified for the unit test. The agent then replaces this type and activates the class. It then executes all unit tests. These now pass and we receive a result. The agent's run is complete. In the next example, we want to generate a wrap object. This time we use a predefined prompt which we simply insert. We specify that we want to create a wrap application, in which package we want to create it, and which prefix we are using. Basically, the classic wrap generator is used from scratch in the background to create the object. That's why the prefix is important. We provide information that we want a wrap entity containing information for documentation, and including fields like title, description, long text, creator, and review. Finally, we provide further information that we want to hide the UUID and administrative fields in the UI. Normally, the wrap generator generates this information automatically, resulting in an overloaded UI with a lot of information that we actually want to hide from our end user. The agent begins working in the system and first queries which system we are working on. Next, it wants a list of the wrap generators on the system. We allow it to do this. That is, it first retrieves a list of possible wrap generators. Then it needs to know which schema the wrap generator requires to function. The large language model then builds the corresponding schema, defines the initial fields, and passes the schema to the wrap generator to create the objects. In this case, the large language model no longer handles the object generation. Instead, the wrap generator is solely responsible for the generation. This is semantically correct and therefore consumes fewer tokens than if our agent were to create each object individually and manually. This is fundamentally an interesting idea for optimizing processes in the context of agents. The object generation process then takes a few minutes before the objects are consistently created in the system. Once the wrap generator is finished, the objects are created in the system, and we can, for example, take a look at the service. At the same time, the agent continues working in the background to hide the UI fields and the admin fields in the UI. To do this, we navigate to the metadata extension next to the service, where we expect changes to be made. After the changes have been made, we can already see that hidden has been set to true. If we scroll down, we also find the other administrative fields, which are now also hidden. Therefore, they should no longer be actively displayed in the interface. Finally, we go to the service binding and click on the inline action for publish to initiate the publishing process of the service. Unlike Eclipse, there's no dedicated button here. Instead, certain actions are displayed inline to initiate the publishing process. At the bottom, you'll find information indicating that the process is currently running. Once the service activation is complete, we find the preview button directly above the service definition and can start the preview of our Fiori Elements application. VS Code then asks us which entity we want to start. The leading entity is already suggested. Accordingly, we now see our application in the UI. We only find the relevant fields which we can then populate. Let's first create a new record and enter some basic information. Here we notice that the model has defined a very short key for the title with only 10 characters. In principle, creating new data records and visualizing them in the UI works. However, it's also noticeable that we can create empty data records, which isn't very practical. Therefore, we want to extend the object again via the agent and include a validation that checks that certain mandatory information is populated. To do this, we switch back to our editor and go back into the chat with the agent. We open the behavior definition, thus giving the large language model some context. Next, we populate our prompt and specify that we want the title, description, and creator to be defined as mandatory. Additionally, it should create a validation that checks whether these fields are actually populated. While we could theoretically set fields to mandatory, we still have to perform the check manually each time, as the framework only reacts to these flags in the UI. The agent then begins analyzing the current behavior definition and starts making initial changes. It inserts the fields that were then defined as mandatory, as well as a validation that is also inserted. We also see that there are still some initial errors, as the fields were also marked with an update flag. The LLM detects this and then changes the field definition to mandatory, removing the status in the process. In the next step, the validation implementation begins, which is also included in the prepare action, so that validation also takes place during the draft. If we then navigate to the implementation, we see that it has been created. Corresponding EML statements have been executed. The data is looped and each field is checked to see if the content is correctly populated. Messages are then generated so that the user receives error messages in the UI if they try to create an empty instance. Finally, let's switch back to the UI. We see that the fields are now defined as mandatory, and we try to create an empty record. We receive 3 error messages. These error messages were generated by the agent. This also ensures validation that we are not creating empty records, but only information that we can then process further. However, we would like to address a few points again when it comes to working with agents within a customer's actual production or development system. It must always be emphasized that SAP resources are centralized. Once they are saved and activated, they reside in the system and are therefore active for every other user. As a general rule, we should check AI-generated code before deploying it to test and production environments. This means that a review process should be carried out by the developer or a second developer. When dealing with version history, please note, if an object is newly generated, there is no version history. If an existing object has been modified, there is most likely a version history, but only to the state at the time of the export. This means that restoring the version is either not possible at all or only partially possible. If you are working with existing objects, you should use explain and ask. You can fall back on this mode, or at least you should make a backup beforehand using a Git repository, so that you can then work with the data and have a way to revert to the original state, if you don't like the results or the agent has stopped making the correct changes. Working with agents is especially useful when you're creating new developments. That is, starting from scratch, migrating things, perhaps to a new environment, creating unit tests in an empty class, or for example, running mockups that you want to discuss with your department. Here it's definitely worth working with AI, as you'll save a lot of time and it doesn't have to be 100% correct yet. Let's summarize the different sessions again. The first version of the MCP server for the ABAP development tools is now available and can therefore be used in Eclipse and VS Code. There are still some minor bugs in Eclipse when the server loads, resulting in error messages. However, the MCP server is generally the first port of call when it comes to a good context for LLM, or when it provides feedback in agent mode to clean up errors that have occurred in the source code. Looking at the features of VS Code, it's still in its early stages for the environment. This means that, in principle, it's already very well suited for cloud development, especially when used with Fiori as a full-stack tool. However, it still lacks support for the numerous objects available in Eclipse, as well as support for various tools like the debugger, data preview, and other tools that developers need on a daily basis. Regarding AI, we can finally work with agents and have various ways to interact with the system using tools and the MCP server. Current use cases primarily involve its use in the web context and the development of classes to leverage the advantages of an agent and achieve speed in extension and development. Basically, the next releases will show what other features are available and how we can further extend our agent with skills in the future, enabling migrations from old coding to the new environment. VS Code is still in an early stage, meaning there are still bugs, and it's not as polished as Eclipse, but you can already make initial code changes with it. You'll also need an Eclipse installation to have the latest tools readily available. However, as recent releases have shown, SAP is very quick when it comes to patching and delivering initial features, so that the ABAP Cleaner, for example, is now available, and objects such as function groups, reports, and classic tables can also be edited. This gives you a first chance to use the editor to edit objects and work agent-based. Thank you for watching, and see you next time.